Welcome everyone to a Seating Dynamics quick class. Today we're going to talk about dynamic seating and a very common concern and question that we hear about shear. My name is Michelle Lang. Thanks for joining us. Shear is a big deal in wheelchair seating, and a lot of what we do is to minimize shear forces in the clients that we're working with. So, in wheelchair seating, shear occurs when the client's body tissues move in relation to the surfaces of the seating system. This can occur during movement within the seating system. So, for example, if a client is extending and the seating system is not, it's a static seating system, the client will move in relation to those surfaces. It could be that there's movement that's occurring in the seating system or wheelchair frame, such as a recline. This also can lead to a disruption in alignment between the client and support surfaces. And then finally, during transfers, and this depends on the type of transfer. If the client is sliding across a cushion heading towards another surface, there is again a lack of consistency in the client contact with the support surfaces. It's changing as they move across the surface of that cushion. Now, shear can lead to a loss of client position. So let's say the client is extending and they move out of alignment with the support surfaces. That causes shear forces. The client then relaxes and resumes their seated position, but the pelvis has now ended up being in a forward posterior pelvic tilt. And because of that, the client not only has extended within this static seating system, leading to shear forces as they move in relation to the support surfaces with their body, but when they relax and sit down, they've now lost their position. Now, why is shear such a big deal? Well, shear forces can lead to tissue deformation, and this is one of the primary pathways that can lead to pressure injuries. So, specifically, shear is displacement of tissue. So, again, we have the tissue out of alignment with the support surface with the addition of friction. This leads to the tissues being kind of bunched up and can reduce or completely occlude blood flow to the epidural layer, that top layer of our tissues. So, this is our latest thought process when it comes to what happens with pressure injuries. And one of the pathways to a pressure injury is this shear force. There are three primary causes of shear forces that we're going to concern ourselves with today. Recline can lead to shear forces between the client's body and the support surfaces. The client may simply slide down within their seating system with the same results. They've moved out of alignment with support surfaces. And it could be that increased muscle tone and or movement patterns cause the client to move out of alignment with the support surfaces. Now, in people who have a lot of tone, a lot of extraneous movement, pressure injury is not as prevalent in this population. But this movement between the client's body and the support surfaces creates a lot of friction. And this can cause abrasions, it can cause friction rashes, and it certainly can lead to a loss of position. So simply because the client's not at high risk for developing pressure injuries doesn't mean that this isn't a concerning situation. So what about dynamic seating? How does this fit into the picture? We know that dynamic seating provides movement within the wheelchair, typically at the hips, the knees, the neck. The primary area of concern when it comes to shear is at the hips, because a dynamic back works by opening the seat to back angle, similar to a recline, and then facilitating a return to upright. So we know that recline can lead to shear. Is there a similar risk if we're using a dynamic back? This is one of the most common questions that we hear about dynamic seating. It's a great question and important to address. Now, recline leads to shear forces as the pivot point is typically not very close to the body's natural pivot point of the hip. And this leads to a loss of alignment with the seating surfaces. So as that seat to back angle opens, often a great deal, the client moves more and more out of alignment with the support surfaces, creating shear. Some power recline systems raise the pivot point in combination with a back which slides down during recline. All of this is an attempt to reduce loss of alignment, to reduce shear forces. In dynamic back design, there's two main features that reduce shear forces. First is the placement of the pivot point. The pivot point must be raised, ideally to a level just above the cushion surface to where that natural pivot point of the hips are at. So here you can see the pivot point of the dynamic rocker back and an arrow pointing to an area of this molded seating system where the client's hip joint is. So it's the top of the cushion that's within that shell. The second design consideration is degree of movement. Now, reclines sometimes can go back until the person's pretty much laying flat supine. But dynamic backs don't move that far. The seating dynamics rocker back moves about 10 to 15 degrees, just enough to diffuse those forces, but not allow the client to move to a point where shear is more likely to occur. So this minimizes the amount of shear, allows the client to remain in alignment with the contours of their back, even a custom molded back, and still benefit from the use of a dynamic back for movement. Dynamic seating can actually reduce shear forces by providing movement in response to client forces. Alignment can be improved and these shear forces decreased. So instead of the client basically standing up within their static seating system and greatly moving out of alignment with the support surfaces, like we see in this bottom right picture, as someone extends within their static system, the dynamic system moves with the client, and this helps them to maintain contact with the seating surfaces. It also means that we've reduced shear and reduced friction. So in this scenario, rather than dynamic seating increasing shear forces, it's actually reducing them because the client is moving out of alignment with their static support surfaces. Dynamic seating allows them to stay in alignment. So bottom line, dynamic seating does not actually increase shear, but rather can decrease these forces for a lot of clients. Dynamic seating can be an important part of a plan to promote alignment with those seating support surfaces. If you have further questions, if you want to discuss this issue or other issues further, feel free to reach out to us. We're happy to have that conversation with you. Thanks, everyone.